So continuing on with chapter 18. So we're on page 2, about in the middle of the page. And so we were talking in the last video about hypothesis testing. And this works with categorical or quantitative variables, and we'll see problems with both. And so last time we found a probability, and let's talk about what that probability means. So the probability that we looked at last time, 0.067, what that means in light of that example. So you remember we had engineering process, and they're making these casts, and normally 20% of the cast would be cracked. They changed the process, and now they took a sample and 17% were cast. And basically that probability was looking at if the cracking rate is actually 20%, what is the probability that you would get a sample where 17% or less cracked? And so we're going to talk a little in this one about what does that mean exactly? How does that relate to kind of what the goal might be there? And so a good analogy for this is a court case. So we always, in a court case, someone's been charged with a crime, begin with the presumption of innocence. And so for us, what that means is we're going to assume that the null hypothesis is true. And in that last example, the null hypothesis was that P equals 0.20, or 20% of these casts that they are making were cracked. So you're assuming that is true. That is beginning with the presumption of innocence. Next, in a court case, you would collect evidence, and this would be collect a sample, take a sample, and in our case, with a categorical variable, we're going to get p hat. And we're going to see how p hat compares to where p is, and how extreme is that, and can we say that that would just be a variation due to random chance, or has something changed? And so then, based on the probability, is the evidence beyond a reasonable doubt? And we calculate a probability, and we're essentially asking, is the probability small enough? So in other words, if we use more of a concrete court example, let's say someone robs a bank, and they are arrested for robbing the bank, and the police have to collect evidence, et cetera, et cetera. So we assume the person is innocent in the court's eyes, and then the prosecution will collect evidence. And so let's say they find you have money in your car, you were in the vicinity of the bank when the robbery happened, and you have a mask, gun, all these other incriminating things. And so what the probability is saying, or is the evidence beyond a reasonable doubt, is if you are innocent, if you are in fact innocent, what's the probability that all of those other things would be true? And so that's kind of what this probability is looking at. So if the null hypothesis is true, then what's the probability we would see our sample, or something more extreme? And so we're going to call this probability a p-value. So the p-value is a probability of seeing data like these, or even more unlikely given the null hypothesis is true. So looking at the normal curve, we have the p in the middle of population proportion, and we have get a sample proportion, and so that's either on this side or on the other side, it doesn't matter. And then what's the probability that we get that or something down here beyond going away from p? So if the p-value is small, then either the null hypothesis is not true, or something remarkable occurred, in which case we would reject H naught. So if the likelihood that we are way down here is small enough, then we can think about maybe this is not true. Maybe P is not actually right there. Maybe it should be down here somewhere. Or if P is not small enough, if the P-value is not small enough, this is not a surprise. So in other words, if your p hat is up here, then you have this big area, and the probability that it is here or less in that case is not small, and you'd expect to get samples around here, and all of these. So these would not be too unlikely. But when you get way out here at the edge, those now we're getting very unlikely, and that's not just due to random chance, probably. And if it is, it's still going to be extremely rare. So then now once you collect evidence and you get a probability that if the person is innocent, what's the probability that all of these other things are true? So the defendant is either guilty, which means the p-value is small and the evidence is clear, or the person is not guilty. The p-value is not small enough, evidence is not sufficient. Maybe they're innocent, maybe they're guilty. Now, one thing to notice when you're interpreting these problems is we're most of the time going to say something is either this or it is not this. We're not going to use, so in other words, we use guilty and not guilty. We don't use guilty and innocent. And we'll kind of see this as we go along. And here's another example. So now we have two choices. We can either fail to reject the null hypothesis if the p-value is large, or we can reject it. So you either reject or fail to reject, or do not reject. So you reject or you do not reject. You're guilty or you're not guilty, and these two go together. If they're guilty, then you reject the null hypothesis. If they're not guilty or the p-value is not small, then you do not reject. And so this is kind of easy to remember because the positive statements go together. Guilty, reject. The negative statements go together. Not guilty, not small enough, do not reject. So all of those not phrases go together. So when the p-value is not small, it is wrong to say we have accepted the null hypothesis. You never say that, and you never say the null hypothesis is true. But what you do say is you fail to reject the null hypothesis. You say there is insufficient evidence to reject. The null hypothesis may or may not be true. All right, so that's kind of the mechanics. And again, I think the most important thing to remember is these positive statements go together. P-value is small, guilty, that means you reject, or the p-value is not small, means not guilty, and we're not going to reject. So just kind of keep those, if you can keep that straight in your head, then things get a little bit easier, I think, when we start working these problems.